Today we will do the new topic of motion chapter, that is acceleration. It is denoted by small a. What is acceleration? It is the rate of change of velocity. Okay, let us try to understand it by taking an example. For example, you are going with a velocity of 20 km per hour, and after 2 hours your velocity becomes 70 km per hour. So when it happens, when you give acceleration to your vehicle, this is called acceleration because your velocity is increasing from 20 to 70. And if you decrease your velocity, then it is called retardation. Now see, this is your initial velocity and it is represented by u. This is your final velocity and it is represented by small v. And this is time taken to reach from 20 to 70 speed. Now I want to find the acceleration of this situation. So I will say A is equal to V minus U by T. That is rate of change of velocity. What is V? 70. That is final velocity. What is U? 20. That is your initial velocity. And how much time taken? 2 hours. So solve this. It will be 50 by 2. So it will be 25 meter per second square. The unit of acceleration is meter per second square. So let us write the formula. A is equal to V minus U by T. If my acceleration is coming negative, that means my velocity is decreasing. So that is retardation. And what is the SI unit of acceleration? Meter per second square. Or it can be written like ms raised to minus 2. Now let us do the questions related to the topic acceleration. First of all, let us understand what is uniform acceleration and what is non-uniform acceleration. Suppose you are going by 5, then it becomes your velocity becomes 10, then becomes 15, then become 20. So it is increasing with a particular amount. Then it is called a uniform acceleration. But if you are going by 5, it becomes 10, then it becomes 11, it becomes 25. In that case, okay, in 1 hour, I am talking about 1 hour. In 1 hour, it is becoming 10, then in 1 hour again, like this. That means a particular equal amount is increasing with equal number of time. Here 1 hour, 1 hour, 1 hour, 1 hour, or 2 hour, 2 hour, 2 hour, in that way. Okay, but here it is not increasing like this. Your velocity is increasing randomly. Then it is non-uniform acceleration. And suppose your speed, your velocity remains same. It is 5, 5, 5. In first 2 hours it is 5, another again 5, and then 5. It is 5 like this. Then we say that acceleration is 0 because your initial velocity is also 5 and final velocity is also 5. So V is 5, U is 5. 5 minus 5 becomes 0. So if your velocity is increasing with the same amount, then it is called uniform acceleration. And if it is not increasing by same amount, then it is called non-uniform acceleration. And if your velocity is not increasing, then your acceleration is 0. So this is the definition for uniform acceleration and non-uniform acceleration. Question number first of page number 103. The question is, when a body is said to be in uniform acceleration? The answer is, if a body travels in a line, straight line, and its velocity changes by equal amounts in equal interval of time, then the body is said to be in uniform motion. That means the velocity is increasing by equal amount in equal interval of time, then it is called a uniform acceleration. Now the definition form for non-uniform acceleration, it will remain same. Here only you change unequal amount. Change by unequal amount in equal interval of time. Then the body is said to be in non-uniform acceleration. Question number 2. In this question, A bus decreases its speeds from 80 kilometer per hour to 60 kilometer per hour. That means its initial velocity is 80 and the final velocity is 60. That means the speed is decreased. And the time is 5 seconds. What is the time? Second. Now see here, this is kilometer per hour and here the time given is second. So first of all, we can't use directly formula here. First we will make the unit same. Here it is hour and here it is second. So we will convert this kilometer per hour in meter per second. So first of all, how to convert 80 kilometer per hour in meter per second. Try to understand this. This means in 1 hour, how much distance is covered? 80 kilometer. So how many seconds are there in 1 hour? 60 into 60. That means 3600 seconds. And convert kilometer into meter. So 80 kilometer means 80 into 1000. So now it is meter. So hour is converted into second and kilometer is converted into meter. So in 3600 second, this much meter. So in 1 second, it will be how much? 80 into 1000 divided by 3600. 20 get cancelled. So the answer is 800 by 36 meter per second. So here 80 kilometer is converted into meter per second and this is my initial velocity. Similarly, I will get a final velocity. So my final velocity will be 60 into 1000 divided by 3600. So it will become 600 by 36 meter per second. It is possible to cancel them, but no need to cancel at present. Okay, now this is in meter per second. This is also in meter per second. And the time is also in terms of second. Now I will use the formula. A is equal to V minus UT. What is my V? 600 by 36 minus 800 by 36 divided by 5. We have to solve this. So A is equal to V minus U divided by T. Now they are in fractions form. So I had written divided by 5 like this. 600 minus 800 will be minus 200. Now this division is converted into multiplication. So 5 will come in the denominator. We will take the reciprocal of it. 5 will cancel 200. It will be 40. I will get minus 40 upon 36. Now it is possible to divide by 4. So final answer will be minus 10 by 9. No need to convert in a decimal form. My acceleration the acceleration of that bus is minus 10 by 9 meter per second square. In this way, we will find the acceleration. Now, question number 3. Question number 3. In question number 3, a train starts. That means its initial velocity is 0 because the train was at rest, and then its velocity becomes 40. So U is 0, V is 40 kilometer per hour and the time given is 10 minutes. First of all, I will convert this 10 minute into second. 10 minute is equal to 60. In 1 minute there are 60 seconds. So 60 into 10, 600 seconds. My T is 600 seconds. Now here this is 40 kilometer per hour. It must be converted into meter per second. So it will be 40 into 1000 divided by 360. So the answer is 400 upon 36 meter per second. Here this is 0 kilometer per hour. So it will be 0 meter per second. Now use the formula V minus U by T. What is my V? 400 divided by 36 minus U, that is 0 divided by T. T is 600. Now this is 0, so 400 divided by 36 into 600. This 36 comes in the denominator. So 2 0 2 0 get cancelled. 4 9s are 36. Answer is 1 by 54. 9 6 are 54 meter per second square is my acceleration. So the answer is A is equal to 1 by 54 meter per second square of that train. I think the question is clear to every student. So in this way, we have to find the acceleration. But always make sure that the speed must be in meter per second when the time is given in seconds or minutes. Our next topic is graphical representation of a motion. First, let us talk about distance time graph. Distance time graph. That means I am taking x-axis and y-axis. This is my x-axis and this is my y-axis. I am only taking the first quadrant. This x-axis represents time and y-axis represents distance. And if I am getting a straight line like this, that means the distance is increasing with increase in time, and equal amount of distance is increasing with equal amount of time. So this straight line represents the uniform motion. It represents the uniform motion. Okay, now if the graph is of this type, that means this is distance and this is time. Here the time is increasing, but distance is not increasing. Distance is remaining the same. Time is increasing, but here this line is not going upward. That means this is the rest position. This is the rest position. We are talking about distance time graph. If there is a straight line like this, it shows that the motion is uniform. If the line is like this in a distance time graph, we say that the object is at rest. And the third is, if the graph is like this, it's a curve. Y-axis, x-axis, distance, and this is time. If this represents time, this represents distance, and you are getting this type of curve, then it is non-uniform motion. This is uniform motion because equal amount of distance is increasing with equal interval of time. Here the time is increasing but the distance is constant. So it is the rest position. The object is not moving. And here it is non-uniform motion because you are getting a curve. So when you make a graph for these three types of motion, you rest, uniform motion and non-uniform motion, you will always get this type of graph. Now let us talk about the velocity time graph. This is about the distance time graph. Second types of graphs are velocity time graph. In this, x-axis represents time and y-axis represents velocity. In distance time, distance velocity. Here in distance time graph, y represents distance and this represents time. But in velocity time graph, y represents velocity and x-axis represents time. Okay, if I am getting a line parallel to x-axis, then it is uniform motion. That means the velocity is constant. The velocity is not increasing, velocity is not decreasing. Velocity is constant. So it is uniform motion and acceleration is 0 here. Because velocity is not increasing, velocity is not decreasing, velocity is constant. So this type of graph in velocity time graph represents uniform motion where A is equal to 0, where velocity is constant. Now second type is uniform accelerated motion. Uniform accelerated motion. If I am getting this type of line, then it is called uniform accelerated motion. This is about velocity time graph. In distance time graph, it is different. In velocity time graph, again, it is different. If it is like this, it is uniform motion. If it is a straight line like this, then it is uniform accelerated motion. Now, if the line is coming downward, then it is retarded motion. Then it is retarded motion. And if you are getting a zigzag line, then it is non-uniform accelerated motion. Try to understand all these concepts. If the line is parallel, it is uniform motion. If the line is moving upward, then that means the velocity is increasing with the time, with change in time. So this is uniform accelerated motion. If it is coming downward, then it is uniform retarded motion. That means the speed is decreased, the velocity is decreasing. And here, if you are getting this type of graph, then we say that non-uniform accelerated motion. Now see, suppose this is the 0. Here the time is suppose 2. And here the time is suppose 5. I want to find out that how much distance is covered by the object from 2 to 5 hours. That means within this 3 hours. 5 minus 2 is 3. So within 3 hours, how much distance is traveled by this object? So I will find this area. If we find this area, we will get the distance traveled by the object from time 2 to 5. We will discuss about this type of equations and this type of questions next time. Now let us see the question answers of the remaining page. Now the question answers of page number 107. The question number 1 is, what is the nature of the distance time graph for uniform and non-uniform motion? We had already explained that for uniform motion, it will be a straight line like this. And for the non-uniform motion, it will be a curve. Okay. Now, question number 2. In question number 2, what can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? That means if I am having a graph of this type, here this is distance and here this is time. So if it is like this, now what type of motion it is? Actually, the time is increasing, distance is not increasing. That means the object is at rest. So here this is uniform motion. This, if curve is there, it is non-uniform motion. If it is parallel, then it is the object is at rest. Now question number 3. In question number 3, what can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? Okay, now here this line is parallel and the graph is distance time. But here the graph is speed time, not velocity. It's a speed and time graph. In this case, we know that the speed is not increasing. Okay, the speed is constant. The time is increasing, but the speed, for example, the object is moving with 50 km per hour, then it is 50 km per hour up to all. So what type of motion it is? It is uniform motion. That means the object has a uniform speed. It is having, its speed is constant. So its speed is uniform. Now in the same question, if it is said velocity time graph, then you will write the object has a uniform velocity. But it is speed time graph, so we will say uniform speed. Now question number 4. In question 4, what is the quantity which is measured by the area occupied below the velocity time graph? Okay, now here this is velocity time graph. If it is velocity time graph, then this area represents Displacement, what it represents? Displacement. If it is speed time graph, then it represents distance. But if it is velocity time graph, then this area below the line represents the displacement. So displacement covered by the body is in the given time interval is represented by this portion. So I think the question answers of page number 107 are clear. Next time we will discuss the graph and how to derive the equations for the motions that we will learn. Thank you.